Hi, this is my walkthrough for COM 3122 Assignment 2. I'll briefly show how I use Python, Pandas, and scikit-learn to complete both parts, covering data cleaning, data frames, visualization, and machine learning steps I implemented. We'll run everything first. I used the COVID symptom dataset that has individual records. Each row is a person with symptoms like fever, cough, breathing problems, and so on. The target column is COVID-19, which tells us whether the person tested positive. This fits the assignment requirement of predicting COVID yes and no. One thing we learned early in the course is that models expect numeric values. Since the dataset uses yes and no, I used get underscore dummies to convert them into binary columns. We practiced this in Pandas Labs, and the idea is the same. Convert categories into something machine learning models can interpret. To evaluate a model properly, which we discussed in lectures, we need to test it on data it hasn't seen. So I used 70-30 split as required in the assignment. The train underscore test underscore split function is part of the scikit-learn, and I chose decision tree because it handles categorical data well and is easy to interpret. And it was one of the first classifier we covered. The model basically learns rules like if the person has breathing problems and fever, then the probability of COVID increases. Model fit X train, Y train. Once the model was trained, I predicted on the test data and calculated accuracy. My accuracy was 98.22%. Go. That means the model correctly predicted the COVID label for about 98% of new examples. In the course, we talked about choosing appropriate matrix. Accuracy works here because it's a balanced yes and no data set. For part B, I continued in the same notebook. This section is basically to show data cleaning, transformations, and exploratory analysis using Pandas, which connects directly to week 3, 4, and 5 of the course. And you can see the data imported. And here, in place equals true. I dropped the data column with in place equals true. Columns, model columns. Then I checked the column list to confirm. This matches the habit we built in labs. Always verify the result after modifying a data frame. And we're confirming. And this is typo. It should be removed. The cost column has some formatting symbols like brackets and dollar sign. I removed them using string replace functions. String replace. Then converted the columns to integer. That's what I'm doing right here. This follows the idea from class that before we do analysis, we must clean our data so types are consistent. I calculated the overall average cost and the average cost per continent. This uses group by, which we spend time on in labs. Grouping lets you compare subgroups. And I plotted a bar chart of grouped mean values. This ties back to our lessons on visualization with Matplotlib and Pandas. Representing summaries visually helps reveal trends quickly. And here, I counted how many times each continent appeared in the continent columns by using value underscore count. Here, all the counts are shown. And I use dot unique. These functions are part of basic exploratory analysis, something we've been doing almost every week. And the total count shows here. Value underscore count. It shows all of them. Okay. And plot a histogram of the cost column. Now I used 50 bins, different. I put labels as well. Okay. And find missing values in zip code and type columns. Summarize all new null values in the data frame. And I used .isna and some. And this shows the statistics for type, including null values, replacing missing type values with XXX. So I'm filling in right here. Include. This assignment asked me to fill missing types with XXX and also to show what happens when I drop rows with any missing values. This demonstrates the trade-off. Filling preserves data, dropping reduces the dataset. Here. So in total, we have 941 rows remain. And here, use Describe to see statistics and fetch the value of the first row and third column of the result. I ran Describe to get summary statistics. Then I use .ilog to access a specific cell. First row, third column. Here, the value. This shows that I understand indexing and slicing, which we use heavily with both NumPy and Pandas. And sorting result. I sorted the value counts of continents. Sorting is a small but important part of data wrangling. It helps when you want organized result before plotting or reporting. So this is the end of my walkthrough. This assignment was nice combination of what we've been doing in the lectures and labs, cleaning data, exploring it, visualizing trends, and applying a machine learning model using scikit-learn. Thanks for watching.